screaming by now because valves are very hot. So this is not a valve. This is a counter. I can stop that light at any one of 10 different positions, which means I can store the digits 0 to 9. So for example, that's a 1. And if I kept that button down and went away for a week and come back, it would still be a 1. So I've got memory. I've got a device that can remember something. So we organise rows and rows of them, 90 rows, and every row is one memory location. We've got the equivalent of about 1/3 of 1 kilobyte of memory. All the early work of British scientists on atomic energy was done on the back of 1/3 of 1 kilobyte. A processor based mostly on relays. Relays were common in telephone exchanges. They're the things that are doing all the clicking. They would have routed your telephone signals across the country. A clock to keep it all synchronised. Lots of relays behind these cans. The cans are there to keep the noise in and the dust out. Control panel and a power supply. It's a very green machine. It's only using about 1.5 kilowatts. Colossus is closer to 8 kilowatts, so you could take this home, put it in your kitchen, plug it into a domestic socket, and it would work quite happily. It might be a bit tall to get through the door, but it is portable, it's on wheels, and it weighs approximately 2 tons. You program the machine by paper tape. You express instructions as holes in paper. And there are 16 different instructions, 4 of which you'd recognise: add, up, take away, multiply, divide, and then there's a load more to let you do your programming. But everything, everything has to be done by numbers. It has no concept of a language. You can't type the word print or add. So here's a program that I prepared earlier. As they say, that's the program that it's running at the moment. That's the program, just a series of numbers. This instruction, for example, 5 means multiply. Multiply whatever it finds in location 39 with whatever it finds in location 68. So everything's numbers, and a real program back at Harwell I think probably would have been 100 times longer than this. And the problem with programs, thank you, is any of you who've done any programming, you know that they never work first time. There's always a bug. So if you have an error and all you've got is numbers, it makes life difficult. So we've got a little button that's going to help us. So no pressure, but you are now in control of the world's oldest working electronic computer. So if you press the button and let go, it will obey the next instruction, which is this one. I saw the Dekatron spin. That means the instruction is being fetched and executed. And at that point, it stopped again, so I can check memory. It's the only RAM in the world that you can read while it's working. Plus 0.68 and so on. I can read it. I can check the instruction that it was obeying, and then I can say to myself, is that what I had intended my program to do? Now, if you press again, you'll see it doing a multiply. This is that 5 instruction. It's taking the digits down here and here, multiplying the 2 numbers together, putting the answer in a special location called the accumulator. Press again, it will clear this bit of memory to 0. They'll all face north. Press again, it will copy the multiplication answer out into memory, and now we can carry on and print it and do other things with it. So it breaks down the whole process. That means it's terribly slow. Thank you. If you were to give this 100,000 multiplications to do, it would take about 17 minutes. So the scientists at the time would have said, of course, first of all, they would have had faith that it's going to come up with the right answer. You've eliminated human error. 2, you're not turning a hand off for 17 days. So for them, that was significant progress. There was talk at one Christmas, they had a big calculation to do, and they literally left it to run for Christmas. They put a telephone line in, and providing they could phone up and hear that noise, they therefore knew that all was well. 11 days later, they come back in, the results are on the printer, all was well. So at the end of the late 50s, the scientists have finished with it, and they should have broken it up like most computers at that time, but it gets given away in a competition to a United Kingdom college, and it's Wolverhampton that wins the prize, but they rename it the Wolverhampton Instrument for Teaching Computing from Harwell. It's called the Witch. That's what we call her on a day-to-day basis, and if you were to put the Witch into YouTube, put witch and computer into YouTube, otherwise you'll get some odd results. But you'll find pictures of it, a video of it, and it gets a lot of hits because of its fame as being the world's oldest machine. Finally ends up at Birmingham Museum in the basement, in pieces, unloved, in the dark for years. And that's where we rescue it, bring it back here, and then start the process that took 3 years of putting it all back together again, servicing it and getting it working. That took quite some time. Okay? Thank you.
Thank you very much.
Where's the USB port?
Well, actually, there are some